Okay, we're going to take a very specific look at one part of the differential equation worksheet for April 13th, worksheet 2, part D. So it's the last part of a 4-part free response question. The first 3 are pretty typical ways in which the AP will assess your ability to work through a differential equation like this. The last one definitely requires a fair amount of abstract thought to get to the solution. And there's actually a number of ways you can go through it. So I'll walk it through kind of my way of thinking about it, but there are certainly other approaches you could take that might get you to a correct spot, or that would get you to a correct spot. But let's take a look at it. So for starters, we're looking at y prime, or dy dx, equal 2x minus y. So that's our actual differential equation. And again, dy dx is slope, or y prime. And then they're asking us in part D, and again, we're just going to look at part D, to find the values of the constants m and b. So we're looking for numbers for m and b. We want values. So our final answer, and I know this seems like a little thing, but I think sometimes it can get easy to get bogged down in a problem and forget what you're actually trying to do. We're trying to come up with numbers for m and for b. And to do that, we've been given this linear function, y equals mx plus b. And they're saying that this thing, y equals mx plus b, is a solution for the differential equation. So this is a solution for that differential equation. So for it to work, or for something to be a solution, what it means is, and I'm going to grab a different color pen here, just because we can. What it means is I need to plug in for y and for y prime. That's y prime. I need to plug in for both y and y prime, and show that the left side and the right side are equal. So in this case, this is y equals mx plus b. So let's just take and plug that in for y. So mx plus b. So that's just going right in there for y. And then on the left-hand side, y prime, I can get y prime on this. And you can do it a couple ways. You can just eyeball it and say, well, I know what y prime is based on the fact it's linear, or you can literally take a derivative. So the left, if you take it, it's just y prime. The right, when you take the derivative of mx, that's just m. And the derivative of b, which is a constant, is 0. So I'll write it here, but technically it's just 0. So y prime equals m. And if you think about it with numbers, if that was y equals, this is just kind of an aside, just for fun here. If that was y equals 10x plus 3, because those are what our answers are, right? We're trying to come up with m and b. These are not the answers, 10 and 3. So this is just an aside. But let's say that's what it was, or we knew that's what it was. If you took the derivative, y prime of 10x plus 3, well, the derivative of 10x is 10, and the derivative of 3 is 0. So there's the m, and there's the b. And that's what we're getting right up here when we do the y prime equals m plus 0, or y prime equals m. And that should intuitively make sense. The derivative is the slope. And what's the slope of a linear function? Well, the slope of a linear function is the number that sits in front of x. In this specific example, it's 10. In the general example, it's m. So long-winded way of saying y prime equals m. So then this is the expression that we get for plugging in for both y prime on the left and then y on the right. And while it looks a little kind of alphabet soup like, it's got a ton of letters and things floating around, and actually just one number, we can actually work with this. So what I'm going to do, and I'm going to step it through a little more slowly than the answer sheet does, I'm going to distribute that negative to the pieces on the inside of the parentheses, and then I'm going to subtract m over. I'm going to have the whole thing set equal to 0, mainly because I'm not even sure what else to do with this. So I have to come up with some value for m and some value for b that make this entire thing equal to 0. Okay, so let's see. I see 2 things that both have an x in it. These both have an x, and then I see 2 things that are just constants. Those are just numeric values. So let's think about that. If I have 0 equals, I could let's see, if I just grab these 2, I could say, well, they both have an x in it, so at a very minimum, I could factor out an x, and I'd have 2 minus m. And these 2, they're both negative, so I guess I could take out a minus 1, maybe? and then I'd have b plus m. That factored form, I was attempting to factor by grouping there, but really I don't have enough in common between the pieces to do a true factoring by grouping. You can actually solve it from this step though, and this is similar to how the solution guide solves it. If you think about it as on the left-hand side, I've got a 0. That means whatever m and b are, so m and b are mystery numbers, I have to be able to put those mystery numbers in here and get 0. The first one to get, and again I'm going to jump colors here, the first one we can get based on this is m. M has to be 2. On the left-hand side, there is not anything with an x in it, meaning I need to zero out the x. So x times it has to be a 0. This has to equal 0. And that's a pretty big abstract leap, but honestly, it's probably the most straightforward way to solve this thing. So m needs to be equal to 2 in order for us not to see any x's, or in order for us to zero that thing out. So that means we solved for m first. So m is 2. Well, once you know m is 2, then you have to zero this thing out. To zero that thing out, if you know m is 2, there's only one choice for b. b has to be negative 2. So to offset the positive 2 that m is, b has to be negative 2. And it's a few more steps than they took on the solution guide, but it ultimately is the way they went about solving it. There's not really like a clean procedural way through this. You do just have to use some intuition. And I'm not going to call it guessing and checking, because this isn't guessing and checking. But you do have to kind of make an educated leap about the fact that we're trying to get rid of x. And that was kind of where we started finding numbers from. And that definitely is a big jump on this one, but that is where the two constant values come from for m and for b. So hopefully that helps and make things a little bit clearer.